Alright, so we're going to start off with factorial. Factorial is really important and the most simple yet fun concept. So let's think about it. By the way, what does factorial tell us? It tells us how many ways something can be differently arranged. Differently and arranged are your keywords. Right? You're gonna see the when you're supposed to use factorial, you will see the word arranged almost every time. लाजमी होगा ये अल्फाज आपके सवाल में आएगा. Now, how do you use it? It's simple. Basically, what now? How does it? Before we get into how we use it, let's get into why it works and how it works. So let's talk about the three letters A, B, and C. I want to arrange them differently. Okay, I can put A first, I can put B, C, that's one. I can put A first again, arrange these, A, C, B. That should be all. Let's put B first now, and A and C, and then B again, and that's going to be C and A. Then let's put C first and put A and B, and then put C first again, and then go for B and A. Total, I don't think there are going to be any more. One, two, three, four, five, and six. So there are six possible arrangements. Now I did this manually, but there was another way. Now before I tell you how, let's look at it another way, like how I came about these conclusions. So first I had like, okay, I could put A, B, or C as my first letter, right? So I had three choices, तीन choices थी मेरे पास. A, B, C में से मैंने choose किया. फिर इसके बाद इतना भी नहीं करना था. After this, I had two more choices. For B, for C, and for A. I was like, okay, I've used A. Now I have two to choose from, which is B and C. After I chose A and B. Now I only have one choice left, which is just going to be C. Same here. I've put two, and I have one more choice remaining, which is going to be B. Same thing is going to repeat here. A and C I can choose from. I chose A, so I can only put C here. If I choose C, I can put A here, right? Now, I want you to think before I tell you. I'm going to do this part. Factorial is essentially how one of your choices limits another, right? And that's how we're going to derive factorial. Anyways, if I put C first, I have A and B. And after these, I'm going to have B here and I'm going to have A here. Now notice all my outcomes have been arranged in a flowchart. But to observe factorial, you see the choices. Firstly, for my first position, I had three positions, three letters to place. For my first position, I had three choices, three letters to choose from. So this spot had three choices, right? One, two, three. After I chose A, or after I chose B first, or after I chose C first. Now every time I'm gonna have two more choices, two more choices, two more choices. So my second spot had two choices. Then the next time after placing A after placing B, the third spot has only one possible choice remaining, right? And so this spot has only one choice left. And now if we multiply them all together, 3 into 2 into 1, that's going to give me 6 as an answer, right? Now what does this define? This defines that I had six possible arrangements I could make. I could move around ABC from different positions. A could go here, B goes there, like I have done here. That's going to add up to six different arrangements. No more can be formed, right? So that is factorial. In one case, when your choices are being limited by your previous choice, and multiplying that consecutively backwards till one will give you how many ways you can differently arrange something. So what is 6 factorial? This is, by the way, the notation. You represent it by a factorial. It is represented by an exclamation mark. Number के आगे exclamation mark put किया. 5 factorial, 3 factorial, and इसके लिए क्या करना है हमें? ABC दिया हुआ है. तीन letters हैं, three letters हैं, so 3 factorial. If this was 4, A, B, C, D, I would have gone for 4 factorial, right? And what you're going to do is you're going to multiply it backwards. 3 into 2 into 1. That's going to give you different arrangements. For 5 factorial, I'm going to do this here. That's going to be 5 into 4 into 3 into 2 into 1. And whatever you get an answer, that's going to be your number of different arrangements. So that is the beauty of factorial. And there is a lot of symmetry involved, but I'm not going to get into that. That's just the beauty of maths, right? But it's not part of your syllabus. That's just for fun. किसी का दिमाग में होता है ना कीड़ा, जिसे हम बोलते हैं उर्दू में, तो उसमें घुसना चाहिए. It's important for your brain to unlock different ways of thinking, right? And this is one as well. Now you're gonna you there is a good question that should come in your mind is, sir, what if a number is being repeated? What if it's instead of being ABC, it's like double AB? Then, by the way, this will be tested as well. That's why I'm revealing this question. So now, again, I had three choices. At first, I'm going to use the same formula. Go for A, and B, right? Now, after putting this, again, I had A as a choice. Then I have B to choose from. Then I had essentially B left and I had A left. Then if I put A again, this whole thing is going to repeat, right? So it's going to be A, it's going to be B, it's going to be A again. Actually, it's going to be B because I've already placed my two A's. And then I have A again here as well. For this, I have two choices. I have both A's. See, and then I have one more choice remaining, which is another A and another A. Now, I want the different arrangements. Let's manually do it first. Manually, okay, let's change colors. Go for this, right? This is one, AAB, and ABA is one, ABA is one. That's 1, 2. That's 1, 2. Then AB has already been done. So this is a repetition. I'm going to mark this with red again. This is a repetition. ABA is again a repetition. It has already been done once, right? So that's still two different arrangements. Then I have BA. Let's change colors again because to highlight the difference, basically, that's all. And that then you have BA. That's a new one, right? So 1, 2, 3. And BAA again, right? BA again, that's still going to be 3 because we're talking about different arrangements. कि अलग तरीकों से कैसे arrange कर सकते हैं. तो तीन arrangements आ रहे हैं. Now I did this manually. Can we do it through factorial? Very good question. Well, firstly, just calculate, despite the repetitions, just calculate how can you, all the possible outcomes, right? How are you going to do that? You're just going to go for, okay, three letters. Three letters can move around in their positions. I go for 3 factorial. दिमाग में रखने की बात क्या है? To keep in mind is 3 letters, तीन लेटर आगे पीछे होके मूव अराउंड कर सकते हैं अपनी पोजीशन से. तीन पोजीशंस में वो मूव अराउंड हो रहे हैं. सो आई वेंट फॉर 3 फैक्टोरियल. द पोजीशंस दे आर मूविंग अराउंड, दैट्स द नंबर आई एम चूजिंग, द मैग्नीट्यूड आई एम चूजिंग राइट हियर, right? Now that would give me 6 ways, but that's not the correct answer, right? There are 3 only possible ways. So when something is being repeated in your the letters here, the letter A is being repeated twice, then what we do is divide your all possible outcomes by the number of letters that have been repeated, right? So the letter A has been repeated twice. So I'm going to go for 2 factorial in the denominator. And that 2 factorial is just 2. So that's going to give me 3 ways. And I have come to the same answer, right? And let's just get into detailed depth of this. What if it was double A, double B, right? So I was going to go for 4 factorial. That's all the possible outcomes. 4 numbers are moving around. And then to remove the repetitions that are going to be seen, we're simply going to put in the denominator the letter A is being repeated twice because they're going to move around and form the same arrangement. That's why we're going to divide by 2 factorial. Then the letter B is doing the same thing. See, different types will be treated differently. So I'm going to put another 2 factorial. The amount something is repeated is put in the denominator to remove the repeated arrangements, right? And just a fun little trick for you guys, if you're dividing by something, 3 factorial divided by 2 factorial, right? So it gives me 3 ways as an answer. Now notice how the actual answer was supposed to be 6 ways, but this division caused 3 ways to be subtracted, right? And those are the 3 ways that were being repeated. Notice it with me. A B एक दफा, A B दो दफा, so that's one repetition, and B A, right? ABA goes twice, 1, 1, 2, and that's the third repetition, right? Because AAB was seen twice, ABA was seen twice, and BAA was seen twice. So that's 3 repetitions that had to be removed, and that is what this division is doing. Now this is just the concept of factorial, and just to tickle your brain a little. Now let's get into the questions. I've compiled a group of questions that will help you with your past papers. They are from the past papers. They helped me through my A levels, and I've compiled them from you. That's just you need to memorize the methods and the techniques, and that will help you tons. So just bear with me. Now, beginning with this question, 10 friends go to dine in at a restaurant and are to be seated in a row. Calculate how many different ways can it be done if there is no restriction. Now, I'd like to highlight a point here before we begin that when how do you know? Because you're going to study permutations, you're going to study combinations, right? After this, and these are all in the same chapter, right? So, how do you know when to use combinations and to use factorial? So, just a small rule to keep in mind is when the things you need to place, right? The things you want to place equals to positions available, and that's just going to make sense in a bit. Now see, 10 दोस्त एक रॉ है जिनमें सबको बिठाना है. 10 friends to be seated in a row on 10 seats. That means they're all going to be seated. The people I want to place equals to the positions I have to fill. So I'm going to use factorial. Now let's learn how we're going to do it. So firstly, they have no restriction. The 10 people can sit and move around. We don't know how they're going to sit, so let's just make 10 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They can all just come, move around, and form different arrangements each time. 10 लोग move around हो रहे हैं, तो 10 factorial. Answer. That's it. Moving on. Among the 10 friends, there's a guy named Ahmed. So Ahmed, I'm gonna call him A, and the 9 friends are the rest of them. Ahmed says he wants to sit on a corner. So कोने में बैठना है बैठ जाओ भाई, कोई नहीं रोक रहा. Ahmed sat on the left corner at the moment. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now he has to be on the corner, right? So this guy cannot move. But the rest of the 9 people can move around and form new arrangements each time. So I'll say 9 people are moving around to form different arrangements while Ahmed remains at his place. Now, just to satisfy the examiner, or your own mind कि भाई हमने 10 लोगों को अरेंज किया, 10 लोग थे, 10 people, we are dealing with 10 people and we're just arranging 9. Just the people you're fixing, the people who are not moving around, give them the value of 1, right? 1 into 9 factorial. Just to keep in mind that you're dealing with 10 things. And but now you'll think we're done, right? Simple. But no. See, Ahmed did not specify on which corner. कौन से corner में बैठना था ये नहीं बोला उसने. मैंने यहाँ तो left corner पे place कर दिया. But now there is another case I can make. I can say, okay, there's one more case. I'm going to add a different case, right? In the same case, when something happens consecutively, you multiply the different outcomes. But when it's a completely different case, you will add. Okay, that's another rule to keep in mind. Now that's the left corner. The same thing can happen for the right corner. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then Ahmed is just going to chill over here. And that's again 9 factorial. So the final answer can be 9 factorial into 2. Easy, right? That's just basic maths. Multiplication is the shortcut of addition. Moving on. Now, Ahmed and Ali want to sit on corners. अच्छा, जिसकी if you have siblings, छोटे भाई बहन अगर हैं तो ऐसा होता है ना कि अगर बड़ा भाई बैठना है वहाँ, बड़े भाई को कुछ करना है तो छोटे भाई को भी करना है भाई. तो siblings में ऐसा होता है. तो friends में भी होता है. In a friend group, when one guy wants to do something, another is like, I want to do that too. So Ahmed says, I want to sit on a corner. I'll seat Ahmed there. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 10. And on the other corner, Ali is like, I want to sit on a corner too. That's Ali, right? I'm gonna box him up. So these are the people that are not gonna move, right? So just 1 and 1 right there, and multiply. But the 8 people can move around, right? And they can form a different arrangement each time. So I'm just gonna go for 8 factorial. They're moving around, right? When in this case, but something can happen here. Keep in mind that Ahmed and Ali did not specify which corners they want to be seated on. If it's specified, I would go for this. This is the answer, but it's not specified. These 2 people can move around about their places, and that's going to be 2 factorial. Now I want to make you think a little. Why did I say 9 factorial into 2 over here, and why am I saying 8 factorial multiplied by 2 factorial? That too, it's the same. It's the same, and I'm putting it here, right? That was for explanation. This is the final answer. 8 factorial into 2 factorial. Now here I've added factorial here. Here it's just multiplied by 2. Why? Because here this multiplication by 2 was just to shorten this plus sign in this whole case. Here, 2 people are actually moving around these 2 positions. See, moving around. एक जगह से दूसरी इन 2 पोजीशन पे हिल रहे हैं. मूव कर रहे हैं जिसकी वजह से 2 फैक्टोरियल आया है अरेंजमेंट. Here it's just another case. Here it's arrangement. Okay, just to make you think. Moving on. Pardi. Ahmed and Ali now want to sit together. पहले शौक से थे भाई कि अलग कॉर्नर पे बैठना है, अब साथ बैठना है, दोस्ती करनी है. So Ahmed and Ali are like, okay, now we're going to be friends. We have the same interest. We want to sit on corners. Now let's just sit together. Let's get to know each other a little. So Ahmed and Ali. Now this question is very repetitive. You'll see this with the letters, with numbers, and with क्या बोलते हैं, capybara जैसे एक word है, with words. Yes, with words. They're gonna like put the two C's together in this word. So that's where you're gonna see this a lot. So keep focus right now. Ahmed and Ali, two people, they're gonna be seated together, A and A. Whenever it's a case of people being together, things being together, put them in a box. Please do yourself a favor. Put that in a box. And the rest of them are just gonna chill outside. 8 people. 1, 2, 3, 4, 5, 6, 7, 8. They can all move around outside. Now, first, do deal with the things that can happen inside the box, right? That they have to always be together. This is the boundary. They can move only inside the box. So that's just gonna be moving around. That's gonna be 2 factorial. And nothing is repeating, right? Like I mentioned in the concept, when something repeats, we divide. But there are two humans, so they'll form a different arrangement. So that's 2 factorial inside the box. Now we're going to talk outside the box. Outside the box, I have 8 people that can move around, right? So that's just going to be 8 factorial. But now you'll think we're done, but we're not. See, this is just when they were on the left corner. They were together, but they were together on the left corner. What if they're here? This one guy goes over there, and then these two are together, and then the third guy is here, and the rest of them can still move. So this whole thing is going to happen again, right? It's the same thing that the 8 people can move around, and the 2 factorials for inside the box. It's just going to be the same thing, but these guys are going to be here. So I'm going to go for it again. But you're going to think I'm done. No, this same thing is going to happen here. This same thing is going to happen here, 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 and here. Now, instead of just going and doing that again, I'll simply just use maths. 2 factorial, 8 factorial. This arrangement has happened how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times. That's going to be 9, right? Now, to make your life easier, what do you think 9 into 8 factorial is? Let's look into that. 9 factorial equals to 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. That's just 8 factorial, right? So 9 factorial is actually equals to, it can be written like this. Don't you see the resemblance? So you can simply say 2 factorial into 9 factorial. So to make your lives even easier, if there is a simple case of them wanting to be seated together, deal with it inside the box. Count this box. I'm going to change colors for a second. Count this box as a position, a whole position. Deal with it in the deal the inside first. 2 factorial. Here you go. This is the way you're supposed to do it. This was just to make you think and learn the concept. Now this is how you're going to do it actually in the paper or when you're practicing. You're like, okay, inside the box, I have these 2 people to be together. I go for 2 factorial. And outside the box, you're going to consider this as one position, as a whole box. Second position, third position, fourth, fifth, sixth, seventh, eighth, ninth. And that's 9 things that can move around. And that's just straight up going to be 9 factorial, and you're going to get the answer, right? Same thing. So that's one way. Now I have this arrow pointed to that question, and that just tests your concept because there is something the examiner can play on. It's probably never going to happen, but it's going to help you out a lot. Moving on. Before we get to that, I'll have some more questions for you. I have some more questions for you. Right, moving on. Ahmed and Ali cannot be sat next to each other. भाई साहब, दोनों ने बात की, नहीं पसंद आया एक दूसरे को, कहा नहीं भाई हम साथ नहीं बैठेंगे, तुम अच्छे इंसान नहीं हो. अहमद ने कुछ ऐसा बता दिया, right? So Ahmed and Ali have a fight now. They do not want to get to know each other anymore. Okay, so how are we supposed to deal with something like this? There are many ways. I'm gonna get into a more complex way in when you're done with permutations. But at the moment, understand this. What if I just say, like in probabilities, when we're supposed to find the unfavorable conditions and we know the favorable conditions, right? So what did we used to do? We would simply go for, okay, we would go for one, that's the total probability. We would go minus the favorable conditions, favorable, and we would get the unfavorable. I'm just going to represent that by dash, right? And we would get the unfavorable. Similarly, I think some people have reached what I'm trying to preach. That rhyme. a little, I guess, in my head. So what I'm going to do is simply, I'm going to go for, okay, 10 factorial is the all possible arrangements. Ahmed and Ali were together. They had one person in between them, two-person between them, three-person between them. Always when it was in this 10 factorial, all the possible outcomes, right? I subtract the arrangements when they were together. That would be this whole thing, the part D. A and 1, 2, 3, 4, 5, 6, 7, 8, 9. And let me just put this whole thing in a box. Straight line. Okay, see, so that's just A, and that's the 8 people. It's the same thing over here. I'm going to bring that back. 2 factorial into 9 factorial. Same thing. Subtracted. So terrible line. 10 factorial. All possible outcomes subtracted from when they were together. The two people will never be together, right? Because I've subtracted when they were together. The arrangements when they were together, and that's just going to give me the final answer. You can just do this in the calculator, no worries. Moving on. Dealing with repetitions, the concept I discussed in the first part of this video when I was teaching you the concept. Simple, really. Calculate how many that's the keyword, different words can be formed by using the letters of the word capybara. I'm using all the letters. See, all the letters are being used. The things I have and the positions I have to fill, they're the same. So I'm going to use factorial. 1, 2, 3, 4, 5, 6, 7, 8. 8 digits that can move around and will give me a different arrangement each time, right? So I'm just going to go for 8 factorial. But you see, A is being repeated how many times? 1, 2, and 3. So just divide that. And that would remove all the repetitions that would be formed by these 3 letters moving around because they're the same thing. And that's going to be your answer. Moving on. Determination, a big word. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 words. 13 letters, sorry. 13 factorial, 13 letters that can move around to give a different arrangement. But E is being repeated two times to give the same arrangement. That goes in the denominator. One more thing is being repeated. I can see the T is 2 times. That's also going to be in the denominator. Then, is there anything else? E कर लिया, T कर लिया, R, no, and I is twice as well. Okay, I is also being repeated twice. So, and E, T, I, A, I'm not seeing it. O, and yep, that's it. N, actually, yes, N is also being repeated. Okay. Are you sure? Yeah, N is also repeating. Oh my god. चलो भाई सारे हो गए. So that's your final answer. Hopefully the concept is clear. Now, before we move to these rare questions I have found, I'm gonna move you here. Strengthening your concept. We are gonna move from this concept to that concept. So I'm gonna play something here. So just keep this concept in mind. Strengthen your concept. Find the number of different ways in which the 10 letters of the word successful can be arranged if exactly two S's are next to each other. Now see, there's a problem here. What is the problem? Successful has 10 letters. Let's just make 10 positions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm supposed to put two S's together. Okay, no problem. Put that in a box. S's are supposed to be together. And the rest of them move around. Easy question, right? No, it is not easy. You see, he wants exactly two S's to be together. But in our word, we have three S's. That means when this box would be moving from position to position, I'll just show you one of the possible arrangements. Let's just put the rest of the letters U, C, C, and then we have an E, we have the remaining S, we have F, we have U, and we have L, right? Now, look at this. Let me just make that neater. Now, when this box will move from this position to this position, new arrangement, new arrangement, new arrangement, new arrangement, but it doesn't satisfy the condition anymore. Now three S's have become together, right? So here it cannot be placed. Here it cannot be placed. Not at all, because that condition will not be met. Here, yes, yes, and yes. So sometimes you will not be able to count this as a position, and instead you're going to have to build on the concept of this box moving from one position to another, right? So it's not always going to be that simple that you can just consider this as a position and go for 9, go for this 2 factorial into 9 factorial. You cannot do that, right? you'll have to think this way too sometimes. So that's just something to keep in mind. Now let's do it properly. Inside the box, two S's, gonna move around, but they're the same thing. S is being repeated twice. They will move around from the same thing. Divide by 2 factorial. That is inside the box. Outside the box, I have 8 digits that can move around. So that's 8 factorial. And this whole thing happens once over here, twice, thrice, four, not here, not here, five, six, and seven. So into seven, right? And that's gonna be your answer. That's just something to keep in mind. That's well. See, this method, this question really strengthens your concept on how you're supposed to deal with putting things together. Now, one more question that will build your concept on repetitions. The examiner pulled off one of the greatest questions on earth. Beautiful question that's gonna make you think. 12 coins. By the way, I would suggest to pause the video and try it yourself, then watch me do it. Okay. Uh, 12 coins are tossed and placed in a line. 10 coin the फेंके, head, tail, आ सकता है सब पे. Heads and tails are the possibility, of course. Now, in part A, it says find the number of different arrangements which contains 7 heads and 5 tails. Okay, simple question. 12 coins, they can all give you all your different arrangements. It could be head, tail, tail, head, tail, head, tail, head, tail. No, it's, I don't know what it can be, but it can be thousands of things. I don't even know what is 12 factorial actually. 12 factorial, it's more than millions. But what I'm going to do, I want it to have 7 heads exactly and 5 tails exactly. What I'm going to do is very simple. I'm going to divide it by 7 factorial into 5 factorial. Can you pick on what I just did? It's very simple. देखो 7 फैक्टोरियल क्या मतलब हुआ, एक चीज 7 दफा रिपीट हुई है. 5 फैक्टोरियल क्या मतलब हुआ, something has repeated 5 times. Now, in terms of context, this 5 factorial, the division I've done represents the 5 tails that have shown, that have appeared on the coins. They're the same thing, right? They're the same thing. Tails, 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 and tails. They're the same thing. And the rest of them are heads. Heads 1, 2, 3, 4, 5, 6, and 7. These were the 12 positions. Blah, 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 blah. 7 of them have repeated heads, so that's 7 factorial, and 5 of them have repeated tails, so that's 5 factorial. All possible, divided by heads being repeated 7 times and 5 being repeated, and tails being repeated 5 times. That satisfies your condition of the coins showing 7 heads and 5 tails. So this is a lovely question. I love this question when it appeared. It's basically wordplay on repetitions, right? It's not exactly telling you repetitions, but you have to think because you're gonna see this a lot, but this is rarely seen. Okay, see, you've done a lot. Damn, congratulations. Let's look at some more rare questions. By the way, these are the questions you need to work on, and these are the rare cases. Now, some questions you should be aware of, very important questions. The digits of the number 1, 2, blah, blah, blah can be rearranged to give many different 7-digit numbers. How many of these 7-digit numbers are even? Okay, now here's a tip. Whenever actually you'll see yourself. Look, 7 positions I have to fill and I have 7 numbers exactly. So I'm going to use factorial. Good. That's one thing I've already found out. Now 7 positions, 1, 2, 3, 4, 5, 6, 7. Why have I made this such a big dash? I'm going to explain. See, what defines a number being even? The last digit has to be an even number. For a number to be, for the whole thing to be even, the last digit has to be even. How many uh, how many different numbers can be placed here to give you an even number? You could say 2, you could say 4, you can say I can when 6 appears here or when 8 appears here, it's going to give you an even number. So there are multiple cases when if 2 forms, the rest of, if 2 is the last digit, the rest of the numbers are going to be outside. They can move around here. If 4 is going to be here, the rest of them can move around there. By the way, I've missed something. I have missed something, haven't I? But actually, I'm going to go back to that. I've forgotten something. I'm going to get back to this, but this is the concept I'm going to build again. Anyways, when there are multiple things you have to place and it's factorial, right? You're working with factorial and you have multiple things to place on the same position. You're going to have to make cases. Now, let me show you how you're going to make those cases. But before that, I'm going to go back to this question. Let's not this question, this question. Let's fix this real quick. When I said 8 factorial over here, this C is being repeated, right? It's going to move around and going to give you the same arrangement. Outside, I cannot just say 8 factorial. I can say 8 factorial divided by 2 factorial. Ah, I forgot, my bad. I hope some of you had got that and fixed it yourself. That would be a proud moment. But yeah, this C is going to form the same arrangement, so I'm going to just divide by 2 factorial. Nothing else repeats, so I'm good. And this whole thing happens 7 times. Okay, back to this question. 2, 4, 6, 8. Okay, so how are you going to make those different cases? So whenever you have multiple things to put on the same position, you're going to have, and it's factorial, right? It's not combinations, it's not permutations. You're going to make a lot of cases. How are we going to do that? Simple. Let's do this again. First case. First, I'm going to place the 2. 1, 2, 3, 4, 5, 6, 7. 7. The 2 goes here, box this up. It cannot move, right? It has to be on the last position for it to be an even number. The rest of them can move around. The 6 digits can move around. But the 4 repeats how many times? Twice. So 2 factorial divided into 1 because I fixed this letter. Plus 1, 2, 3, 4, 5, 6, 7. Now place the 4 here. A 4 goes here. Outside 6 numbers can move around. This is 1. I'm going to move on. Now why haven't I divided by 2 factorial? Because nothing repeats. See, this 4 has been fixed here. And the 6 numbers that are moving around are all different. So no need to divide. Moving on to the third case. 1, 2, 3, 4, 5, 6. 7 numbers is a 6. 6 goes here. Fixed. Then we have 6 numbers that can move around. And the 4 repeats 2 times. That's going to be here. Then I'm going to do the same thing with an 8, blah, 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 blah. And 8 goes to the last position, tup, tup, then, yep. 6 factorial divided by 2 factorial into 1 because the 8 is fixed. So overall, there are 4 cases that can be simply written down as 6 factorial divided by 2 factorial into 3 because once with 8, once with 6, and once with 2, the same thing has happened. So just to make my work more neater, I'm just going to write it this way. Then a fourth case was of just 6 factorial when we put 4 as the last digit, right? So that's just going to be 6 factorial. Different cases add, same cases multiply. Anyways, and that's just going to give you the answer. See, that's just the answer. That's something you need to keep in mind as well. And by the way, this is going to be test. This is actually in the recent years, I've not seen a question like this, but in the, I guess, back in 2015 onwards, you're going to find something related to this. And you never know, right? So you have to know the tricks. Moving on to the final questions. I'm glad some of you have made it to this point of the video. Congratulations. Really pat yourself on the back because it's a big deal, dude. This can be really boring sometimes. And I'm trying my best to make it as fun and as logical as possible. And this is all going to be worth it. Trust me, it is always worth it. Anyways, final question. Now this is a different one, right? 1, 2, 3, 4, 5, 6. 6 letters have been given to you and are used to form a 3-letter number. How many ways can it be done? Can this be done if every letter can be repeated? Now this is a special case. See, you have 6 letters and you have to form a 3-digit numbers. The things you have available is 6, but the positions you need to fill is 3. Now you would say, okay, I'm not supposed to use factorial here. Now this is a special case. When it says every number can be repeated, you will still remain at factorial regardless of your positions and the things you have available being the same or not. If it says each number can repeat, you will remain with factorial. Now why does that happen? Let's look into that. See, you have 3 positions to fill. 1, 2, 3. Make these huge boxes. Now what when I was telling you about the concept of factorial, I told you we were replacing ABC, right? ABC. Now for the first position, I had 3 choices, then I had 2 choices, and I had 1 choices. They were happening consecutively. I multiplied them. I got my 6 ways. Now here, if you notice something, see, I have 3 positions to fill, right? Now the first position has all numbers available to it. All 6 numbers can be placed on the first position. Now as I move to the next position, this choice will have to limit my second position to just 5 more choices because 1 choice has been made here, 1 number has been chosen here. The second box now only has 5 choices. That would have been the case if it was not specified that a number can be repeated. It says each letter can be repeated. मतलब क्या हुआ इस बात का मतलब ये हुआ कि it means when 6 numbers were available to this, a number has been put here. That same number can also be used here. This choice does not affect the number of choices for this position, and hence this position is also going to have 6 choices. This position will also have these 2 choices, do not impact the last position, the number of choices available for the last position. No limits have occurred, and this is also going to have 6 options. It's just consecutively happening, same thing, 3 letters now complete, and you multiply them consecutively. 6 cube is your answer. So when it says a number can be repeated, stick to factorial, please. Right? And my friends, that would be everything in my opinion. That in ways basically the examiner can fool you or maybe trick you. We're gonna do the past papers in the end. When I'm done with all 3 lectures, you're gonna find them in the end of the playlist. So if that's gonna really help you out, and if you do it yourself, that's gonna be brilliant as well. And yeah, and I would piece of advice would be to just pause the video, go back to the start, and do all these questions for yourselves without me being the voice of guidance, right? And it will help you out. Definitely.